Hello, I am Cody Tuftee, team lead presenting on behalf of my teammates Ben Agnello, Kelsey Harvath, Kaechele, and Niemi. We are Senior Design Team 7 from the Biomedical Engineering Department at Michigan Tech. Our sponsor for this project is the Systems Engineering Research Center of the United States Department of Defense. The military is interested in monitoring the health and well-being of cadets during rigorous training missions. Extended exposure to environmental factors such as heat and humidity can be a safety risk to trainees. To combat this risk, our team was tasked to design a system of body-mounted sensors that remotely monitor the health of cadets during long field exercises. This will increase the safety and effectiveness of Army training missions. To address these needs, we propose the integration of commercially available sensors that measure specific physiological signals into a larger system. The parameters of interest include body temperature, hydration, heart rate variability, and heart rate. After comparing commercially available sensors, we identified that the Garmin Vivoactive 4 smartwatch, core body temperature sensor, Polar H10 heart rate monitor, and H-drop dehydration sensor best fit our criteria. We developed a plan to test the sensors on human subjects and display the information in a single display in a manner that is easy to read and interpret. Since the hydration monitor can only connect with its associated app, that data was obtained separately and analyzed. Based on the criteria and the solution we proposed, we programmed the various sensor outputs to integrate with a microcontroller. The sensors were linked to a Raspberry Pi using Ant+ software. We were able to display heart rate and body temperature in real time. The heart rate variability is calculated in the background and monitored to provide warning when the individual is at risk of arrhythmia. After obtaining IRB approval, we conducted a pilot study of 22 participants consisting of an even split of males and females. The main purpose was to determine the accuracy of the hydration sensor. Upon arrival, the participant changed into a paper smock and their body weight was taken via a digital scale. The participant began the treadmill test. The test consisted of walking up a 1% incline treadmill for 4 15-minute increments with progressive speeds broken up by 10 minutes of rest. After the test was completed, the participant changed back into a paper smock to collect their final body weight. The sweat loss from the H-drop sensor was compared against the change in body weight measurements on the scale. The testing of the H-drop was a crucial part of the project, for it is currently the only commercially available hydration sensor on the U.S. market. No studies on the product's efficacy were available, and a pilot study to determine the accuracy against body weight change was necessary. During testing, it became apparent that the product's percent error calculations against physical body weight were alarmingly high. After collaboration with H-drop, we received new algorithms to run our data through. The error values improved slightly, but not significantly enough to validate the H-drop sensor for our system. In conclusion, we determined that the H-drop by itself cannot be relied on to measure hydration levels accurately. On the other hand, the Polar H10 chest strap and core temperature sensor performed as reported in literature and company specifications. We were also able to integrate this data through Ant+ software to be remotely displayed on a monitor. Here, skin temperature, core temperature, and heart rate were able to be observed in real time. In the future, the Garmin smartwatch could be integrated with the live status view. There are also more sensors that are being developed and brought to market which may prove to be more reliable than the H-drop. We would like to thank our advisors, Dr. Rao and Dr. Jiang, as well as our sponsors from the CERC and DoD, specifically Captain Shepard, Major Donovan, and Staff Sergeant Raymond. Thank you for your attention.